Thank you, Scott.
And there we go.
So David, you said you are getting some rain in Arizona?
Oh yeah, we had some a couple of days ago, quite a bit, and we're expecting to get some later this weekend and pretty much all through next week.
What about the fires? Has it helped with the fires any?
Oh, it certainly has helped with the fires in southern Arizona. And in fact, right now there's some very serious cloud buildups, cumulonimbus buildups I can see right outside.
Yeah.
So we're getting much needed, badly needed rain right now.
Oh, I bet. Errol, how hot did you say it was there today? Because it'll probably be here tomorrow.
It was 98 in the car about an hour ago.
Yeah, gosh. Woo. Yeah.
Yeah, we'd be glad to share that if we get something better behind it.
If you get any good weather, give me a call. I know it'll be headed my way. Clear skies would be much preferred.
I agree. It's kind of partly cloudy here today, kind of getting ready for the rain, looks like.
Yeah.
There's Chuck.
Here he is. How are you guys?
Ah.
Welcome.
Thank you.
Hi, Chuck. Good to see you.
Hey, David, how are you doing?
Pretty good. I'm doing all right.
You're going to tell us how to forecast all the weather, right, Chuck?
I am. Meteorology
All right.
101. Yes.
We need all the help we can get.
That's exactly right.
How many here have a sky quality meter?
I do.
I do.
Carol, you're the only one
You
not
gotta-
raising your hand.
You got to get one and be in the Cool Kids Club.
I guess I'm going to have to do that.
Yep.
Actually, I borrowed from Scott Kranz.
Oh,
He's
okay.
alerted to those.
One of you guys needs to borrow it from me. You can do that too.
You know, it's been so long since I've been anywhere. I really hadn't thought, because I usually pack it and take it with me wherever I go to check the skies. And it's been so long since I've been anywhere. I forgot about even taking that.
Yeah.
Does that just generally check sky conditions, light pollution?
Measures magnitude per square arc second of the sky.
Okay.
It's logarithmic, so there's a world of difference between 21.5 and 22. But 21.5 is roughly Bortle 2, maybe low 2, and my site ranges from maybe 21.20 to 21.45. Not ideal, but adequate.
Well, Michael, you might be interested in knowing that Natural Bridge, 21.5. So it's
Wow.
Okay. Excellent.
Are you headed out that way?
Hopefully we are soon as a club. John's working on setting that up for later in the year when the nights get a little longer, I think, but that would be some great conditions for viewing and imaging.
Oh, yeah, definitely.
Michael, what's the name of that site?
The one that John just mentioned was is it Natural Bridge in Rockbridge County?
in Natural Bridge State Park in Virginia. There's one in Kentucky too, I think, but no, this is the one in Virginia. And it was privately owned since the time of, what's that guy? Thomas Jefferson. And it,
Wow, really?
yeah, privately owned until about 6-7 years ago, when that current owner was getting up there in years and he wanted to do something for the community, for the state. So he offered to sell it as not national park, as a state park. And as a result, this place has very little light pollution.
Wonderful.
In fact, at the main observing spot, when you look out over the vista, there are no lights. So the nearest lights you're really going to see are many, many miles away. It's a good place.
About how far is it from a populated area?
Well, from my house, it's about 52 minutes.
That's not bad at all. Yeah.
Yeah, from Roanoke, it's time-wise, I guess it's 40 minutes, maybe. I don't know.
A normal day at work is very different day to day because you never know what's going to happen. It could be anything from planning an outreach event, or you have meetings all day long where you're planning for an upcoming event. Things change all the time, but we're always planning for the next event. We're always planning for the next activity. My name is Stephanie Clark, and I am the outreach coordinator for the Hubble Space Telescope. I've always loved science. I have a degree in kinesiology, which is exercise science. I've always loved earth science in particular, biology, and just how things work. I've always found that really fascinating, so I wanted to pursue a career in science, and I've always loved working with people. I've wanted to work with children my whole life. This job gives me the ability to do that and talk to kids about science and space, and it's just really amazing when you see that a kid learns something new. You can kind of see it in their face, and their face kind of lights up, and they're kind of like, wow, that's really cool. And it's like, yeah, this is really cool. My number one responsibility is planning and coordinating outreach events, coming up with new materials that are interesting for people to engage with when we're at these outreach events, to giving teachers the tools that they need to spread along the word for us. That's a part of it too, is, you know, provide the materials that they can use to inspire creativity and inspire wonder. My favorite image is Star Cluster Westerlund 2. I just think it's absolutely beautiful, the colors and seeing all the stars, it's just amazing. The thing about working on a project like Hubble is that it's the reason why you know what you know about space. This is amazing. This stuff is going to be in textbooks, the stuff that Hubble is providing, and this is going to be impact on the world forever. And then you kind of realize, hey, my kids are going to be learning about this one day, and I'm a part of it. It's an amazing feeling. But when you take a step back and you talk to other people, and you go to events and you talk to kids, and you see how, you know, they want to be an astronaut, or they want to be a scientist, and they want to use Hubble for a certain thing. It's just amazing. To me, that's the best part.
Well, hello, everybody. This is Scott Roberts from Explore Scientific and the Explore Alliance, and it is my distinct pleasure to introduce the executives of the Astronomical League that are live with us today on the Astronomical League Live number 8. Terry Mann puts together these programs, so I will turn this program over to her, but I was just thinking about Terry and all the time that she has spent under the stars, all the time that she's devoted to the astronomical community at large. She has been the face of the league for a while, but she has also been someone that has been behind the scenes a lot, and she's ever present. And I think that I'm grateful that she has devoted all of her energy and time to encouraging amateur astronomers around the world to get involved and to go to the next level with the Astronomical League. So I'm going to turn this over to you, Terry. Thank you very much.
Thank you, Scott. And thank you, everyone, for being here. We have got a great program tonight. So, David, how about if we start off with you, David Levy, and thank you so much for being here again. We really do appreciate it.
Well, thank you, Terry and Scott. It is my pleasure to be here. I've been a part of the Astronomical League for many years, I think it is an absolutely first-rate organization. And I like it particularly when they work with the Royal Astronomical Society of Canada. So we're really all rascals when we do that, I think. Anyway, I always begin these sessions with a little what I think is an appropriate poetic quote. And I have to admit that I am not a happy person today. I learned only yesterday that my godson, the son of a very close friend of mine, Christopher Scotty, passed away yesterday very suddenly from a liver failure. And so in his memory, I'm going to read to you Sevilla Martin's poem written in 1905, which I revised in 2014. My eye is on the sky. Whenever I am tempted, whenever clouds arise, when songs give place to sighing, and when hope within me dies, I draw closer to the sky. From care it sets me free. My eye is on the sky, and I know it watches me. My eye is on the sky, and I know it watches me. Thank you. Back to you, Terry.
Thank you, David. I'm sorry to hear about your friend. That's too bad. Yeah. And thank you. That is such a beautiful piece of poetry there. So how about if we check with Carol, and we will let ask Carol to do an update on everything that needs updated.
Thank you, Terry. And David, that was beautiful. I always enjoy your poetry. I was looking the last few days at the proofs for reflector articles, various reflector articles, including the Observing Awards, and it became very apparent that there is still a lot of observing going on out there, even through all this pandemic. Individually, people are out there, our members are out there still looking at the sky, which is so encouraging. Maybe our outreach events are down, and they're down considerably, almost non-existent, but individual observing is still there. People are doing that throughout the whole pandemic. So that's very refreshing. Another thing that I'd like to talk about is I think Chuck and Terry may say more later, but I'll just generally say it, and I won't steal any ammunition here. But 2021 virtual is coming up very soon, Alcon Virtual. And if you had talked to us a year or so ago and says, why don't you do a convention online if you're not able to do it in person and see what happens? I said, well, yeah, but how would we do something like that? Well, the answers are several members of the team on this program today, Terry, Chuck, Scott, John, everybody has really been active in making this all happen. And it is just incredible, the generosity of our member clubs. We're now up to, I think, $7,600 and counting as far as door prizes. When we ask for volunteers at the executive league level of who might be interested in heading that up, Terry and Chuck both enthusiastically jumped in and says, we'll take a shot at it. And they've really done a fabulous job. There are, in fact, we almost have a problem. We've had so many donations. We're wanting to make sure we have enough time for our speakers. It's a good problem to have, so it'll work out all right. The one thing that was sort of also brought home to me within the last couple of weeks is that, yes, we're moving out of the pandemic, but we're not quite there yet. I had a cousin, second cousin, just within the last week who passed from COVID. So that really brought it home that, yeah, we're getting close, but we're just not there yet. So yeah, we can do that. You know, we can get out there and follow CDC guidance, and it's just being smart. If we're in some groups that we're not used to, we don't know people have been vaccinated, we can always put a mask on. And I know that has some discussions, but we can put the mask on and really protect ourselves and others. So just a word of caution there. The other thing is we will be looking more at future Alcons coming up at our council meeting in a week from now on the 17th. Right now, of course, we've got Albuquerque in 2022, and we'll have other presentations for 23, 24, and 25. So it's a good problem. We've got them scheduled that for events. And I think that's the extent of my comments for right now. Terry, back to you.
Okay, thank you, Carol. Appreciate that. We do. We have a lot of things going on right now, a lot of different things that we're looking at and scheduling and getting ready for. And it's actually amazing. And I am seeing more star parties coming back live. It looks like August, September, I'm seeing more and more coming back, which is really encouraging because I'm sure I'm like everybody else. We're kind of ready to get out there again under the stars some, but cautiously, as you said, so I'm looking forward to that. And I'm definitely looking forward to Alcon in Albuquerque. It'll be nice to be able to actually see everybody again. It's been a while.
That group has been so patient. They've stayed with us for 3 years. So we're very appreciative of that.
Very much. Yeah. And got a great program. So I am really looking forward to Albuquerque too. So, all right. How about John Goss? Would you like to go ahead? You have got something really cool to talk about that I'm looking forward to. So, John, I'll let you take it away.
Thank you, Terry. Before we start on that, I'd like to talk about a couple other things really quickly, and I may be jumping ahead to maybe what Chuck is going to say. I just want to briefly mention the 75th anniversary of the Astronomical League. And there's a lot to say about it, but really what I'd like to say is that we have a pen, a lapel
Yes,
pen
you do.
right here, which
Very nice.
you will all be seeing more of this as time goes on. Everybody on the screen I see will be seeing more of this pen. So keep your eyes peeled. Okay, I have something else. Well, I might as well get right into it. This year, this month, here I'm talking about the 5th anniversary of the League, but this month is the 5th anniversary of something really special as well. And I'm afraid it is something that we just forget completely about. But it is actually a very fantastic thing in our lives. 50 years ago, at the end of this month, was the moon landing of Apollo 15. And I'm kind of sorry to say that, much like it was back then, by the time they got up to number 15, a lot of the public just kind of, wasn't too interested in it anymore. They weren't nearly as excited as for Apollo 11 and the others. But 15 was a pretty cool mission by itself. Let me see. I got something to share here, I think. Let's see if I can do this. Okay, good. I'd like to start out by talking a little bit about Apollo 15, 50 years ago at the end of this month. It was at the Hadley Ridge area near Mount Mons Hadley in the Apennine Mountains. You might remember hearing about the Hadley Rill. It was the first mission of the lunar rover. That was a big thing. But where a lot of us might remember the mission was the elementary physics demonstration given by one of the astronauts, which he whipped out a falcon feather. Falcon was the nickname of the spacecraft. Whipped out a falcon feather and had a trusty hammer, held them up in the vacuum, and dropped them both onto the lunar surface. And just as physics predict, they both fell at the same rate and hit at the same time on the surface. That was a great demonstration, which I think is still available today, certainly on YouTube somewhere. But it's something to keep in mind that this mission provided us some pretty, not just entertainment, but some interesting science as well, because they collected a lot of rocks in 3 excursions at the eastern edge of Mare Imbrium. And so there was a lot of geology that they could do and help figure out more about the moon. Enough about that, but keep that in mind. In late 2018, I was developing a series of questions, 300 trivia questions for the moon. And one of them, one general topic was about how large the moon really is. There are many different ways of figuring this out or asking it. One way is by comparative analysis. I happen to come across a statistic saying that Mare Crisium was about the same size as the state of New Mexico. Well, okay. You look at the moon and look at Mare Crisium, you think, it no way is in any shape or form like New Mexico. It's kind of oblong, kind of squashed north to south, and it just doesn't fit. Well, I started thinking about that, and it occurred to me, well, the reason is because of lunar foreshortening of the disk. That it played a very big role in this. So what is foreshortening? And that's what this talk is going to be about, lunar foreshortening. Foreshortening is, it occurs because the moon is really a sphere. It's not a disk, even though in our sky we think it's a disk, or it sure looks like one. But the closer you get to the limb, that is the edge of the disk, the lunar surface curves away from you. And the closer you get to the edge, the faster it curves away from you. So if you're like 70 degrees from the center of the lunar disk off to one side, it curves away about twice as much, about 3 times as much as you move along the disk. So it curves away quite rapidly, which accounts for this lunar foreshortening. I'm going to bring up some high school trigonometry. Now, maybe I won't. it'll be a minute when I do that. So I have an image here that I took in my iPhone of the moon through the telescope. Okay, so I cropped the Mare Crisium out, blew it up a little bit so you could see it, and measured the aspect ratio, physical size of it. Then I stretched it. Now you might remember back from high school trigonometry, they may have mentioned something called a secant. And I remember it because I was thinking, there's no way I'm ever going to use this. Secant, it's really just an inverse cosine of the angle. So who's going to use secant? Well, this is one instance that comes in pretty handy. The secant of the distance in degrees from the center of a disk or from a sphere measures the amount of stretch that's required to correct for the lunar foreshortening. So
Don, can I interrupt you for just a minute?
Sure.
Are you sharing your screen?
I am sharing my screen.
Yes,
I don't see it.
I do.
Oh, I don't have it. Okay.
Yeah, I see it.
I can see it.
Yeah,
Yep.
it's broadcasting.
Okay. For some reason, it's not showing up on mine. Okay. Okay.
I'm seeing it just
Well, if
fine.
everybody else sees it, that's okay. I can't see anything but you.
Just get it fixed before August, Terry.
Yeah,
All right,
that's
Chuck.
This is a practice run.
Yeah.
I just hate it when that happens, don't you? How awkward. But anyway, I'll try to describe it then, what we're looking at. We're looking at that cropped image of Mare Crisium stretched about 1.5 to 3 times its width ratio. Okay, big deal. Well, take a look at the Lunar Reconnaissance Orbiter picture of Mare Crisium. When it's pretty much directly overhead of that sea, you can see the images look pretty much alike. So when you do some stretching on the computer, you can gain an idea of what the moon really looks like in a 3D perspective. Just to complete this, I took the Lunar Reconnaissance Orbiter image and then scrunched it down, compressed it 2.5, 3 times. So it now resembles number 5 there, resembles what we would see through a telescope. So these are the steps. I'm not going to go through this, but these are the steps 1, 2, 3, 4, and 5. Getting the original image, cropping it, stretching it, comparing it, and then compressing it again. So it's kind of a full circle, and it really does work like this to show you what's on the lunar edge. I could do the same thing on the western edge of the moon with the crater Grimaldi, but I'm not going to go over that because it's the same operation, but it's could be time consuming if I go through all this. So this led me into something else. I was reading a little bit about the history of manned exploration of the moon. Well, really back in the early 1960s, before anyone had been there, NASA was trying to get a handle on what the moon really looks like. So there was an experiment done by a person whose name I think was William Hartman, who took a ball, a large sphere, and projected a very high resolution image of the moon onto that sphere. Then he could walk around to the side of that sphere and see what's kind of right on the edge. And I won't say he discovered, but he helped uncover the mystery of Mare Orientale, which is on the side of the moon, something that people couldn't see. And I'll get to that again in just a moment. So we're going to talk about something completely different. Now, as Michael can say, because he was at the club meeting when we did this, this makes for a really cool, a really great in-person demonstration at a club meeting. Since we're going to start meeting again, I hope, with clubs maybe in August, September, October, this might be something to try out because it's completely different. What you need is a 12-inch ball about. I tried it with a 9-inch, too small, an 18-inch ball. It's pretty large to do it with that. So like a 12-inch beach ball. And what you should do is paint it with primer. And then you paint it with ceiling white. So you have a nice white ball. Then you get a computer projector, which is, you can see in the pictures, the thing down below. I didn't have one, so I had to go to our local library and borrow theirs. So most of this is what you're going to see is taken at the library. And while I was doing this, I attracted quite a bit of attention from the library patrons. So I had a room of people watching me do this. So I was on the spot and worried I was going to goof up, which of course I did. But anyway, so what you want to do is position the ball and the projector precisely, so that you can project an image onto that ball. And what happens when you turn out the lights and project an image? Hit the ball and you can project an image of the moon right on it. Now, this is, if you haven't seen this before, it's pretty stunning because
Cool.
I'm the observer. I'm right there, and I'm within 2 feet of this ball, and it sure looks like I'm within 2 feet of the moon, orbiting around it at just a few thousand miles above it. It is pretty strange to see. Point out just a few features on the moon, which a lot of you know already. There's your Mare Crisium over there on the right-hand side on the far eastern edge. Crater Plato up towards the northern end. Copernicus kind of towards the center. Grimaldi, which I mentioned a few minutes ago, off on the western side. And then Tycho, which is a lot of people's favorite crater, is down towards the southern edge. So what you can do, you have this ball. You don't really have the moon in front of you. It's just a beach ball. And you can go up to it and sit down and look up towards Tycho, get a picture of that. And you can see what Tycho would look like from an observer orbiting the moon in the far southern portion of the moon. Mm-hmm. If you look on this picture, you notice that Tycho is elongated slightly east to west or left to right. Well, when you're directly above it, it's round. And again, that's lunar foreshortening. So you get a completely different perspective of the moon, a different view. You do the same thing on the north side with the crater Plato. From our point of view on Earth, when we look at it through a telescope, it is, again, elongated left to right or east to west, but really it's round. And that's simply because of lunar foreshortening. Now, what was really cool, really surprising, and I think I can get a lot more work out of this if I play around with this some more, but I want to show you what happens when you have a movie of the moon rotating. So you're standing there, as I said, 2 feet away from this thing, and it really looks like the moon is rotating. There you have the far side of the moon coming up to the right, the center. The round dark area is Mare Smythe. I'm not sure if that's how to pronounce it, Mare Smythe. And just to its upper left is Mare Crisium. Again, it's no foreshortening there. You can see it really is kind of elongated east to west. And then the rest of the moon comes around. I swear, you're sitting there thinking, I'm orbiting the moon. It's right smack in front of me. If you're having this for a demonstration, this would be a good time to invite all the people in the club to get up. You know how it is. You're at your club meeting, people sit in their chair and they stay there for 60 minutes. Well, this makes them get up out of their chair and walk around to see the different sides of the ball of the moon. And it gives an interesting effect. For instance, to show you, drive it home more about this lunar foreshortening, there is Mare Crisium on the far eastern edge of the moon, and I'm standing there with my camera, really only about 2 or 3 feet away from it, and I walk around it. So there you can see the terminator on the moon as well.
Yep.
There's now's the elongated shape of Mare Crisium. Now you can continue this on the other side, but I don't want to get too repetitive here. Pretty strange stuff. I don't remember what this was on. We'll find out. Oh, okay. We have the rotating moon again. And this is the one which I'm walking around while it's rotating. And yeah, there's me in front of the projector. So of course there's the white ball. There is no moon there. And then they're off to the sides first projecting on it again. And then again, there's Mare Crisium right smack in the center. No foreshortening at all. It really looks like that. You're standing 2 feet away from it, looking down at this thing. It is strange. Okay, as I said, when I was filming this at the library, there were a bunch of people there watching me. And, you know, I'm nervous and I'm filming this and my elbow hits the ball. So it goes, I destroy the moon. And it goes flying off, bouncing on the floor. I'm an idiot. You know, kind of put it back, try to get everything lined up again, redo it. We had some good Snickers in there. I think they were suitably impressed with this. So just a review on what we have said. We're talking about the three-dimensional moon. This makes for a great meeting demonstration. It's something that your club members will find completely unexpected. All you do is you need a white ball, about 12 inches in diameter. They're pretty easy to find this time of year, a beach ball. Paint it white. I need a stand for the ball, so you got something to rest it on. Computer projector, which are pretty common these days. And then download a movie, probably from NASA, of the rotating moon or whatever. Just to tell you something else about this, I did try this with a rotating image movie of Mars. It doesn't look nearly as dramatic as the moon. I guess the contrast differences. Mars is just kind of the big orangish red rotating thing. Yeah, doesn't have the mare that the moon does. But the critical thing is you got to have the precise alignment with the projector and the ball, or otherwise you'll get some weird shadows on it, and it'll look kind of funny. But this helps you view the effect of foreshortening. If I have time here, one more thing. Okay, let's go back to Grimaldi and Mare Orientale. Just wanted to tell you a little bit about this as well. As I was saying, in the early 1960s, people did this, projecting it on a ball, and they could walk over and see Mare Orientale, kind of, not really, but they could tell that there really was something there. Here's my lame photograph of the deal here. Got Grimaldi there, and you can kind of see the ripply, rough areas of Mare Orientale right on the edge. Okay, this is what I see. Well, on our spinning ball, there we have Grimaldi there, and right in the center is Mare Orientale, and you can see the round nature of the basin and the concentric rings of the mountains caused from the impact. This is an interesting. I say this is an interesting feature on the moon. Actually, it is probably the most interesting feature on the moon. That if Mare Orientale was placed directly in the center of the near side of the moon, it would be the most dramatic object on it and one of the most talked about in the solar system. So we would definitely see it. So, something to keep in mind here. Then there's the Lunar Reconnaissance Orbiter picture of it. Same thing, Grimaldi there, and then you got the round basin of the Mare. And so now we know what it looks like. With that, I'd like to stop my share, but one more thing. That's the star of the show right there.
Yeah, a lot of people wanted to know how this was exactly done.
I'm not kidding when I say it's a beach ball. In fact, if you look closely, you can see the little striations in it. And it's just primer and sealing white on it, a couple coats. That's all it is. Put it on a stand, hit it with your elbow, and you'll destroy the moon. That's it. That makes for a really interesting, thought-provoking club presentation, because it starts to get you thinking about what you're really looking at when you're looking through your telescope. You're not looking at a disk, you're really looking at a sphere. And that's how your view is affected. On that note, any questions?
How when you're projecting the image, is it just a standard projector of just a standard image of the moon?
Yeah, well, what I wanted to get a fairly high resolution image of the moon so it would look nice, but I just went to the NASA site and snooped around and found a nice image of the full moon. What I didn't show tonight was looking doing the same thing, but like only projecting a first quarter moon on it, or a crescent moon or something, to see how that would look. That's pretty dramatic as well. As long as you have something that has a fairly high contrast image. Lunar highlands are pretty light, and the Mare are pretty dark, so you can get some good contrast that way. So there's
wonderful.
Yeah. Okay, well, that's what I have, and I hope you all try something like this. It's thought-provoking.
That's amazing, John. Thank you.
Okay.
I'm sure we're going to have more questions about that. Have you got something on the League Facebook page about this? There needs to be something on the League Facebook page.
Well, I certainly could. In fact, you saw I have 4 or 5 movies. I could splice it together and put it on YouTube and put it on Facebook. Yeah.
Either that might make a nice YouTube presentation. I mean, if you wanted to get into more detail about it, because I think a lot of people would probably be interested in using that as a demonstration. I know I would be.
Me too.
But that's amazing.
Yeah, I'm kind of speechless when I do it, because
I
said, you're only 2 feet away from the spinning moon.
Well, being underneath it, shooting up to Tycho, I mean, that makes you think. So yes, please put something together, kind of detailed, maybe on the League website on Facebook, or the League Facebook page, and that way people can access it. If they have questions, they can come in on the League Facebook page and ask questions. But I think that's an amazing outreach project. Can you imagine at a star party before it's dark, or inside a building and darken the room, especially if it's a night when the moon is out?
Well, as I said, it also gets people out of their chairs, because they have to get up and walk around to really appreciate this thing. Get up right to it, as opposed to sitting 20 feet in the back of the room. You got to come right up to 2 feet away, and it's impressive.
That's what I was going to say. When John presented this at our club meeting, I think 2 or 3 years ago, I had some of my students that were just randomly visiting that night. And the first thing they wanted to do after the presentation was run up and just stand next to it. And you don't always get that with every presentation. Like it's a very interactive thing.
Yeah, very hands-on. That's
they just loved it.
I bet. Well, that's amazing, John. Thank you so much. I look forward to seeing that on the League Facebook page, and something we can print out and work with a little bit. So thank you so much. All right, Chuck Allen, you about ready to go?
I think so.
Okay, well, I will let you take over.
Okay, I'm going to go ahead and share screen here for a moment, if I may. Okay. Looks kind of dark right now, doesn't it? Okay, here we go. I set up my telescopes at a place called Patoka Lake. It is on a peninsula about 65 vertical feet above the lake, next to a pavilion that's never used, in a field that is always mowed and has 4 great horizons. It couldn't be a more perfect place. It's in the middle of the Hoosier National Forest. And I go in all conditions, such as cold conditions, for example. This was the end of a night in which I observed for 10 hours, and it was -2 degrees at the low point during the night. But it was actually a very productive night. This was after I'd already shut down the telescope and had put one of the tables away before leaving in the morning. Those who know me know I do a lot of visual observing. I used to do a lot of astrophotography back in the 80s and 90s, but I got hooked on these observing programs for the League. And so I've been going up there a great deal, and I'm leading up to something that has to do with weather here. That's what we're going to be talking about. This is the number of all-nighters I've pulled at Patoka Lake in the last 3 years, 74. The problem, however, is that Patoka Lake, this observing site, is 72 miles from my home. So it's not a trip I want to make unless I'm sure it's going to be clear when I get there. That's a very critical element here. Among the things that I need to know before I make that trip are, first of all, is it going to be cloudy? Is it go or no go? Secondly, what kind of transparency am I going to have? Am I going to have any high, thin clouds? Am I going to have haze? Am I going to have smoke from forest fire somewhere? I need to know all of that. I'd like to know what the seeing conditions are like. A lot of the galaxies that I hunt for, it really isn't that critical, but some of the other observing I do, it is critical. Dew and frost. Am I going to have the heaters on high as I start out, or can I start at a low setting and work up to it? You want to stay ahead of dew and frost. Those of you who've had trouble with this on your secondary mirror, on your corrector plate, or on a refractor objective lens know that you fall behind in this fight and it's hard to catch up again. Temperature is also important. I always tell people to dress for Alaska, even on the hottest summer days when you go observing, because the temperature can drop like a rock at night. So the question is, how do I make these predictions about when to go and save myself a needless 144-mile round trip? I use 2 services. One's called Clear Sky Chart that many of you are familiar with, and the other is called Spot Weather, or Spot WX is the abbreviation it uses. If you combine the information from these 2 models, you're almost guaranteed to have the weather you're expecting when you get to your site. And we're going to look at both of these tonight. And so just to give you an idea of those 74 all-nighters that I pulled at Patoka Lake, that was out of 76 trips. 2 of the trips got ruined, one by fog that I couldn't have anticipated very easily. And the second was affected by an odd band of high clouds that came in that were not projected. But the success rate in using these 2 sites in predicting whether I should go to Patoka on a given night is running about 97 to 98%. It's that effective. This is one evening as I left the house to go observing at Patoka. It was pouring rain. By the time I got to Patoka, it was bone clear. It was a beautiful night all night long. And I did this in reliance on these models. So let's take a look at these weather models and see what they have to offer here. I'm going to shut that down now and go, first of all, to the Clear Sky Chart. And here you see it. Many of you who have been around amateur astronomy for a while are very familiar with this. It is a chart that provides information about cloud cover, transparency, seeing, and other conditions at a given number of sites. Now, it's run by Attila Danko and Alan Rahill from the Canadian Meteorological Center is the one who created the forecast models that are used in this. If you scroll down here, you'll see a list of provinces and states. And you can, for example, I can go to Indiana where I observe, click on a map right here, and a map of Indiana comes up. Now, right here is the Patoka Lake observing sites. Okay, so I can click on that and get information, and we'll look at this in a little bit. If you live in an area where there is no site, maybe there's a large area, only Indiana is marked here, so there are plenty of sites in Ohio and Illinois as well. But if you live in an area where there's no marked site, you can apply to Mr. Danko for a site. May I get my own chart? It's at the bottom of the homepage. You can go down here and just email him, give him longitude and latitude, give him the name of the site you want, and he will plug in a new site for your observatory. I have friends who do this even for their backyards. You can call it your home observatory or whatever you want, and it's very effective. So let's look at a couple of examples of how this might work. I'm going to pick one in Maine. These are going to go to the map of Maine right now, and we're going to go to Eustis Ridge, which is right here. And you click on that little marker there, and then you click on the little link right here, and the clear sky chart for Eustis Ridge comes up. Now, this shows a roughly 2.5 to 3 days period of time, and it provides local time across the board here. These are all local times for Eustis Ridge. So this time right here, for example, is 5 a.m. on Sunday, July 11th. You can, let's take Saturday night, for example. If under cloud cover, if I put my cursor right here at 11 o'clock, you'll notice the little white pop-up says 10% covered. So I've got some cloud problems at midnight, 10% covered at midnight. And then at 1 a.m., it's clear. So I know that from 1 a.m. until dawn, I'm going to have clear skies. The transparency marked here, however, is not as perfect. It is marked as average. There's above average and then transparent. Transparent would be very dark, like this blue color right up here. There is a legend down here for cloud cover transparency and seeing that will tell you what the color codes mean.
Hey, Chuck.
Okay. Yes.
Chuck, I'd like to say something. I don't know if anybody else is having problems, but I can't see your screen share, or it's frozen. I don't. Several slides ago, and it hasn't changed. Is that just
when
me?
he went to the map, I thought it was me again. When he went to the map, I lost it.
It might be selected to just be sharing the PowerPoint presentation, and then when he went out of it, it might have stayed in.
Okay, so just stop sharing, Chuck, and then go back to reshare.
All right, hold on a minute.
That should fix it.
All right, let's just close that. No, I can't get back to full screen.
I just love causing problems.
Yeah, I'm glad you said something here. Something's frozen here.
Chuck, if you want to.
I'm going to stop share. There we go. Okay. Now I'm going to re-share screen. Okay. Can you see my desktop?
See your desktop.
Okay. All right. Let's try this again. Sorry about that, folks. We're going to go to Clear Sky Chart. Tell me if you can see the Clear Sky Chart homepage.
Yes.
Okay.
Yes.
Yeah, it looks good.
Yes.
All right. Thank you for calling that to my attention, John. We might have gone too far here without it. Okay, I'm going to go, do you see a map of Maine now?
Yes.
Okay, I'm going to click on Eustis Ridge. And do you see the Eustis Ridge Observatory
Yes.
chart? Okay. Here again, we're looking at Saturday night. If you can see my cursor right here, we're looking at, I'm hovering over the little block under cloud cover at midnight. And it says 10% covered in the little white pop-up right underneath that. At 1 o'clock, it says clear, 2 o'clock clear. So I know I'm going to have clear skies during this period right here in the morning. The transparency is listed as average. That's not good news. It's not bad. It's just not above average or fully transparent like we'd like it. Seeing conditions are good. That's excellent, especially if you're doing double star or multiple star work, that kind of thing. There's a smoke line here that provides information about forest fire smoke, and we'll look at that in just a minute. And again, the legend for cloud cover, transparency, and seeing is down at the bottom of the page, down at the bottom of every page, no matter what observatory you pick. Now I'm going to back up a couple of pages here and go to a different site in Nebraska. Okay, I'm just picking these at random. And here's a place called Starlight Ridge Observatory. I click on the pin and then I click on the link right here, and the chart for Starlight Ridge Observatory comes up. Now, maybe I'm trying to anticipate when I'm going to be able to observe next. It must be obvious that that's going to be Sunday night. Sunday night's looking really good here. Now I can click, if I want to see just how clear it's going to be, I can not only hover over 12 o'clock on the Monday morning, where it says clear in the pop-up, I can also click on it. And when I click on it, a map comes up that actually shows the cloud cover chart for that whole region of the country.
Oh, wow.
And I can actuate the image down, activate the image, animate, excuse me, the image down here with this link. And now I can hit this button and it will show the movement of clouds. Here's the observatory location. I can see, according to the time up in the left-hand corner, when clouds will be coming in and when they will be leaving the area. I can also stop it and advance the image 1 hour at a time. If I'm interested at a particular time, maybe let's say 7 hours UT on July 11th, I can see I'm going to be right at the edge of a cloud bank that might be leaving the area. Nope, it's coming in, so I've got troubles. You can also, amazingly, with this site, you can also click on the little block for transparency, and it will actually give you a transparency map that's also animated, if you wish it to be. Now, there's the location of this observatory. It's in a dark area, which means very transparent. And you can animate it to see. Again, the observatory is located right here in northern Nebraska, and you can animate it hour by hour to see when areas of bad transparency are coming in. And you can do the same thing with seeing conditions, although I do that less often. You could click on this block here and get a map that will actually show you seeing conditions across the country. It's a little bit of a hard map, but you see the seeing conditions in the middle of the plains right here are pretty good at this particular time that's listed up here. And again, you can animate that and change the time hour by hour as you need to. Now, we've decided we're going to observe on Sunday night. Everything looks great. No cloud cover, transparent, seeing conditions are good, but we've got a problem down here. Look at the smoke. We've got a problem right here. If I hover over this bar here, it says 5 micrograms per cubic meter of fire smoke coming from forest fires. Now, I can click on this. It may not work, but I'll show you what you do if it does. I'm going to click on this, and it did work. This shows, here's the observatory under this cross right here, and it's in an area of fire smoke coming from Western Ontario. And so I'm now concerned that this is going to affect my transparency, and trust me, it does. This is the kind of stuff that makes your daytime sky look kind of milky white, and it certainly cuts your transparency during the night. And so once again, you can advance this hour by hour. Here's my observatory in Nebraska if I'm from that place. And you can see when the smoke is moving out and when it's moving back into Nebraska. Boom, there it is, coming in from forest fires in Idaho. Very useful there. So now I have to make a decision whether I'm going to observe on this night because of the smoke problem. It's moderately bad at this point. So that's something to consider. So you make your decisions on observing using the clear sky chart. But I always like, before I make that 72-mile trip, I like to back it up with a second opportunity, a second opinion, if you will. So I go to a source called Spot Weather, or Spot WX, and this is what Spot WX looks like. Now, I can type in the location, any location I want, or I can just zoom in and pop my cursor anywhere I want. I When I go to Patoka, I type in the name of a little village called Wickliffe. It's very near Wickliffe, Indiana, which is very near where I observe, less than 2 miles away. And this allows me then to go down below to a series of models that provide forecasts for periods. I use 4 of these models. I use the 18-hour forecast that I've highlighted here, the 21-hour forecast here, the 3.5-day forecast here, and the 10-day forecast located here. Now, Sunday night for Starlight, Nebraska. Let's see if, let's suppose smoke was not a problem, and it looks like it's going to be clear. Starlight, Nebraska is roughly right here. So now I can look at my 3.5-day forecast, and it will pop up this chart. And lo and behold, look at Sunday night right here. Looks clear, no cloud cover, 0 clouds from about 6 or 7 p.m. right in the middle of the chart here to the right. I can then go up here and click on, let's say, midnight or 1 a.m. in this case, and I can see temperature in centigrade, maybe the dew point in centigrade. And if I don't like that, I can go up here to the right and change units. I can change Celsius to Fahrenheit. I can change wind to miles per hour, precipitation to inches, save that, go back to the chart and look at Sunday night. Now I see the temperature at 1 a.m. is going to be 67 degrees Fahrenheit, the dew point 51. That's a 16 degree difference, which means very low humidity. I'm not going to have dew problems on this particular night. That's good news. Am I going to have wind problems? Not at all. I come down here, find out the wind's going to be 2 miles per hour with gusts of 2 miles an hour. That's virtually 0 breeze. This is full confirmation that I should go ahead with my observation, provided that the smoke is not an issue, which unfortunately it is. Now, I looked the other day to see what my July was going to look like. And to do that, I wanted to see what the next little period of time is, 10 days. So I used the 10-day forecast for Wickliffe, Indiana. Highlights Wickliffe. I click on 10-day forecast, and it's just awful. Rain, 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 the entire rest of the lunar cycle. So I'm out of business for the July cycle from this point on. The 10-day obviously is not as accurate as the 3.5 day. The 3.5 day is really good if you're anticipating maybe on Wednesday or Thursday, am I going to be able to observe this weekend? And then when you get to the morning of the observation, you use that 18 or 21 hour forecast to get a really accurate indication of whether to go forward. If both spot WX and clear sky chart agree, you're probably in great shape for your observation that night. These models are terrifically accurate. It's shockingly so. And again, the only surprises I've had were very rare over those 76 trips that I've made up to Patoka in that time. So that's it. I will stop share. And if there are any questions, I'll be happy to answer them.
Let's see. No, but I think probably everybody's writing down that website, Spot WX.
Yeah.
That is really amazing. And a lot of us amateur astronomers knew about Clear Sky Clock, but I'm putting that Spot WX website up there. And Attila Danko is, gosh, what an amazing guy he is for, he's had this up for maybe going on 20 years, something like that.
Yeah.
And many amateur astronomers swear by it, that's for sure. And I've never heard anybody swear at it. So there you go.
Well, weather is notoriously unpredictable, but with these satellite models, seeing the patterns, these computer models have really gotten it to a point where if I'm going to go out and have an activity outdoors, whether it's observing or not, if I'm worried about whether there's going to be freezing rain, these charts are fantastic. Spot WX will give you rainfall totals for your area by the hour. It'll tell you about freezing rain, snow accumulations, at what time during the day. So it's a great predictor if you've got to drive somewhere or make some plans for outdoor activities as well.
right?
All right. Well, thank you, Chuck.
Sorry, I didn't know I had my camera off.
Yeah. Since I messed up the first time, I've been trying to text everybody and say, what's going on? Okay. Thank you. My gosh, that was an amazing first hour. I have learned so much. Thank you all. Why don't we take about a 10-minute break, Scott, and we're going to
Okay.
come back with Michael Martin.
Okay, sounds good.
Okay, thank you.
John, that was excellent.
Yeah, John, I have a question. How big do you think you could make? I mean, how you could make one of those spheres?
You're muted, John.
You're muted. You're
Muted.
muted. John. We can't hear you. No. There we
Now-
go. Yeah.
The problem is the brightness of the image. If your projector, I don't know how these things are rated, but if the projector is very bright, you can have a much larger ball. Otherwise, your image dims down. But that's why I was saying that the 12-inch ball, at least for the one I was using, it worked out very well. An 18-inch ball, it would have been better, but the image just wasn't bright enough. It was bright, but it just didn't give that impact as the smaller, brighter image.
Mm-hmm.
I didn't answer your question.
But a very bright projector could do a.
Yeah, I got a really bright one, and was going to use it at NEAF last year. And I think you could use a black sheet as a screen for this thing. So it would probably work great for that, for an 18. I'll have to try that.
Absolutely.
Do you have a link for that particular video, John?
Someplace. Yeah, I can send it to you.
Okay, thank you.
It's just off a NASA site somewhere.
Mm.
Another issue is that the ball, I said I was using a ceiling white paint. If the ball is reflective, you get a lot of glare. It reflects right off of it. So you want to get it as dull as you can. That's why the ceiling white was working well.
So you've got to find a dull beach ball.
There's a question here. Just curious, can you see or observe asteroids with the telescope? What can be used? What does NASA use? Can it be observed, like since some are predicted?
Absolutely. There are hundreds of asteroids within the range of small telescopes. And there's a chart, a site called In the Sky, that will provide you with charts for asteroids that are available at a given time, especially the brightest ones.
One of the parts of the solar system program for the Astronomical League is to track an asteroid over maybe 3 to 5 nights and then see how it changes against the star field. And that really makes it very real for you that these are, separate things from the background of space in our solar system. It's just, you're really just tracking a little pinpoint of a bright object, but just to see it change from night to night is a pretty incredible thing.
For me, one of the most impressive things that I have actually seen was an asteroid that came very close to Earth. So it moved across the sky very quickly. And using a telescope, most astronomical objects don't change, certainly not within minutes. But some of these close passing asteroids, you can actually watch it slowly move across your field of view. As it scoots by the Earth and the Moon. But interesting to see.
Excellent. I posted up the ALPO's minor planet section for people who might be interested in getting involved in maybe some of the, more research level, amateur research level type work on minor planets. What in the observing programs with the Astronomical League, is there one for minor planets?
Yes. Yes, there is. There's an asteroid program.
Okay, great.
Actually, there are 2 programs. You have the
near Earth, near Earth objects too. That's a little harder. I think 40 to complete that program and 100 to complete the asteroid program.
Right. So anyways, I will transfer this back over to Terry, but there was that little question there from a guy who goes by the handle of Splash. So
No problem. Thank you, Scott. What I'm going to do, I'm going to share my screen. Before we go to Michael, I forgot to ask of the 3 questions for the door prizes tonight. So I'm going to share mine. And as Carol kind of spoke about earlier, we will have Alcon Virtual coming up. There we go. That is coming up in August. We have got an amazing lineup of speakers, an amazing amount of door prizes. You just can't miss with this. There's so much going on over the 3 days, and the clubs and the individuals have came forward to donate door prizes, and it has been amazing. And we thank everybody that has done so much, that they have done so much for the door prizes. And Scott, you and Explore Scientific are right there too. And we thank you very much for all your help broadcasting for the Grand Door Prize Saturday night, which will be a telescope, a 127 millimeter MacCast telescope with a twilight mount. And that will be amazing. That will be given away Saturday night. We've got speakers. We've got 2 or 3 more that will be added. We're working on bios and getting last minute details together. But as you can see, we've got Dr. Jocelyn Bell Burnell, discoverer of pulsars, Dave Eicher, Kelly Beatty, Alan Dyer, Dr. David Levy, Paul Cox from Sleuth, and I've got the rest behind. Anyway, we've got so many speakers and so many door prizes. Please register. Understand, when you register, your email is not going to be sold. We're not going to load your mailbox with emails. It is only to notify you if you have won a door prize. We have to have a way to contact you. That is all registration is for this. So let me go on. Tonight is Astronomical League Live 8. Tonight's door prize is going to be a tote. 3 of the winners, each one will receive a door prize, and it will be that tote that you see on the right. And send your answers to secretary@astroleague.org. And please answer your questions as fast as you can, because tonight is different than the global star parties. While the main speaker, while Michael Martin is speaking, I am going to be finding the winners for the totes. So please answer the questions as quickly as you can. If you watch this later, it's already over with as far as the door prizes. So please just answer the questions as fast as you can. And Carol will be sending the winners a letter of congratulations and getting your information of where to send the door prizes to. So as I said, secretary@astroleague.org. On what date was the final shuttle launch? On July 3rd, Sunspot AR 2838 did something we haven't seen for 4 years. What happened? And the last question, what is the approximate dollar amount of the door prizes for Alcon Virtual? We've got great door prizes, thanks to all of our clubs and everybody that donated. And that is it as far as the questions. So I'm going to stop my share and let me introduce Michael Martin. The title of his talk is going to be The Joy of Astrophotography and How to Share It with Others. He has had an interest in amateur astronomy from a young age, brought upon by my faith and love of science. In my early 20s, I began to get serious about the hobby by exploring the night sky and documenting my observations through a blog. In the past 5 years, I have joined my local astronomy club, RVAS, and enjoyed working on several AL observing programs, having recently completed the Messier and Solar System certificates. For my day job, I'm a high school social studies teacher, where I also sponsor an astronomy club for the students. Beginning in 2020, I started to film and produce observing guides, product reviews, and astrophotography tutorials on my YouTube channel, Late Night Astronomy. When I'm not teaching about politics or studying the stars, I spend as much time as I can with my wife, Lauren, and my daughter, Lily, who just turned 3. So Michael, welcome, and we look forward to your talk.
Thank you so much. And you may hear that 3-year-old running down the hall on and off as she gets ready for bed. Thank you for that. Thank you for that wonderful introduction. I've been a member of the Astronomical League now for 5 or 6 years, and I really appreciate all that you all do through the local clubs and chapters and nationally and internationally just to promote the hobby for others. So Terry, when I got your email of invitation, I really appreciated the opportunity tonight to talk a little bit about my journey through the hobby and specifically astrophotography and sharing it with other people. So thank you very much.
You're welcome. Thank you for being here.
All right, let me screen share here. And if at any point it's looking like something isn't presenting correctly or isn't loading correctly, just please let me know. Or any questions that we may have throughout it or saving them for the end, whatever y'all would like to do would be completely fine with me on that. So I'm about to start a new series on YouTube called The Joy of Astrophotography. And pretty much just looking at how to image things in the nighttime sky and just what I personally get out of that in terms of, as you said in the introduction, my personal faith and also just my love of science that I've had for as long as I can remember. I got my first telescope when I was 5 years old, back in 1992 for Christmas, not to put a date on my age one way or the other. I've got an 8-inch Dobsonian telescope now. I love visual observing. I love astrophotography and imaging, and there's just so much we can do in this hobby and obviously share it with others through a variety of ways. So I got into astrophotography in 2009, and these were the first pictures I had taken of Saturn and Jupiter. And I was thrilled with these. I took a digital camera. I didn't have an iPhone yet or a smartphone, so I took a digital camera, held it right over the eyepiece, and just clicked snap to take a picture. And I was just blown away that you could kind of make out the rings of Saturn, kind of make out Jupiter. As time has gone on, I've added new equipment. I use a DSLR camera now almost exclusively for all of my imaging for planetary and deep sky. And over the years, those images have turned into these images. So I think it's really good, regardless of what you do in the hobby, just to keep logs or documentation of what it is you've observed and what it is you've imaged, just so you can go back and see how far you've come over 5 years, 10 years, 15 years or more in the hobby. The picture you can maybe make out in the middle there was the first shot I ever took of the Orion Nebula with, again, just kind of a point and shoot digital camera, not on a tracking mount, just on a tripod. And I could make out a little bit of blurry detail in the middle, and I was thrilled with that. And then this is an image that I took of the Orion Nebula with some newer equipment about 4 months ago. So just kind of to start off with where I was roughly 10, 11, 12 years ago to where I am today, talking through for you all how I got to where I am now from the starting point that I had roughly 10 or so years ago. So I think the best place to start for anyone in terms of imaging the nighttime sky is to start with the moon and planets. And the beautiful thing about that is you do not need too much expensive equipment to do that. Go outside with a point and shoot camera, with a cell phone, and take a picture of a crescent moon right after sunset. Take a picture of Venus, which is the brightest object in the western part of the sky right now and is just beautiful right after sunset. Just take those pictures, start with what you have. Don't feel like you have to jump into the deep end with thousands of dollars of equipment to start to explore the nighttime sky. Begin with what you have and have that be the starting point for what may come down the road. For me, the telescope and the cell phone was when I first started to get a little more seriously into astrophotography. just using whichever iPhone I had at the time. I think this was the iPhone 10 that I was using to image here. I bought a $20 camera adapter just to kind of perfectly put it over the eyepiece that I had, just to really show what I would see through the eyepiece. Now, you're not going to be able to make out many deep sky objects, or hardly any at all, with this type of imaging, but the moon and planets is going to be some remarkable things that you can photo, image, and record to share with others. So just take pictures, just take video, and just keep working at it with what you have. Even if you don't have a telescope, but especially if you have a telescope, to get in closer on these solar system objects. And the incredible thing about what we're able to use today is it's a fairly standard thing on most newer smartphones to have 4K and even 8K video recording capabilities on some of these cameras, and even at higher frame rates of 60, 120, some of them can even do 240 at full HD. And if you get a little deeper into image processing, that's a really cool thing. But even just posting it online at that resolution can be a really neat thing to do as well. Using the techniques that I just showed right there, as my 3-year-old daughter runs by the room. I've got this video right here I took of the moon using my 8-inch Dobsonian telescope, my iPhone, and I just let it record. And this is a perfectly beautiful video that you can just post and share online for your friends and family to see. No processing done with it at all, just a good, simple video of the moon. Moving on to the planets. These also were captured with, I think it was my iPhone 6 at the time, but we've got Saturn and then Jupiter, these two videos moving across the field of view right here. You can make out the Galilean moons. This is no processing at all. This is just the raw HD video that allowed me to go through and to do that with these videos that we had. Regardless of your starting point in astrophotography, don't be shy about sharing what you take. I think it's a very easy thing to go onto Instagram or Facebook and see images and pictures that are gorgeous and beautiful from NASA, from people who own thousands or tens of thousands of dollars of equipment, and say, well, what I have doesn't really compare to that. You really can't look at it that way. This is your image that you own, that you took, and it's very personal to you. So share the picture of the moon that you took, whether you think it's a great one or not. Share Jupiter, share Saturn, Venus, whatever it is you're able to initially take. Share it with friends, share it with family. Don't be shy about that. I think that's something that we can kind of get caught up in, is always comparing our work to others, particularly with astrophotography, when there's quite a bit of that out there right now on the internet with some remarkable resources to help out. So to start off with, use what you have. If you got a telescope, that's great. If you got a smartphone, use that. Take some images of the moon and of the solar system. Let's say you do that, and then you decide you want to move on to the next level. You want to move on to maybe the next price range in terms of astrophotography. For me, that was buying a DSLR camera. This is the same DSLR camera that I use to take pictures of my family. It's what I use to record my videos for YouTube. It's what I use for a lot of different things. You can get these used on eBay for $200 to $500, and sometimes even less than that, depending on the model and how old it is. I bought a T-ring adapter that was about $10, an extendable camera adapter, and then I did need, for my telescope's focal ratio, a 2 or 3 times Barlow lens, depending on what I was imaging that night. Typically 2 times for the moon, and then I use a 3 times one for the planets. I bought just a budget Barlow lens, got it off of eBay for $25. Very affordable equipment in terms of the Barlow lens and the adapters for that. So you're going to mount this to your telescope, and I've got a video here kind of going through what I do for a normal night of imaging. This was for Venus about a year or 2 ago. I go in and I connect it to my telescope. I make sure it's at the fastest frame rate possible. I go in and adjust camera settings depending on the quality of the sky and the image that I'm looking at. You go in and live view and kind of tap to zoom in, and that kind of helps you do a fine-tuned focus of whatever the object is that you're looking at. Checking focus throughout the video recording a few times is important when you're getting different shots of it. But this is what it looks like connected and set up to my camera. And once I've found the object, once I know what I'm recording, everything's set up correctly, I press the record button and I let the camera float across the field of view for anywhere from 30 seconds to 60 seconds. It depends on whatever it is I'm imaging that night. I don't have a telescope that tracks, so it is floating through the field of view. Sometimes those pictures are good enough to post, just doing those videos like that. But if you want to go deeper into it, there is some tremendous free software out there that I use for these. The first one is PIP, Planetary Imaging Pre-Processing. The second is AutoStacker 3. AutoStacker 4 may be out or may be coming out soon. I read an article about that around the start of this year. And Registax 6, which Registax 6 has not been updated for quite a while, but particularly with the wavelets that we'll look at in a second, it's just incredible at bringing out fine surface detail, particularly on Jupiter and Saturn. So all of this software is free to use from dedicated groups of individuals or small teams that put it together. And it's excellent to use. So I've taken my video of the planet moving across the field of view. What I want to do now is process that. I want to pick out the best frames of those videos. So I was shooting at 60 frames a second. The higher the frame rate, the better. At 60 frames per second, I'm going to have software go through and pick out the sharpest frames with mainly just the atmosphere. It's going to take those sharp frames, it's going to stack them, and that's going to allow me to go through and do some pretty incredible things with the equipment that we're using here in this presentation. So to look at this example here, let's load up PIP and open up a file that we have of a planet that we imaged. I think this example here was an image or video I took of Jupiter. So we've got Jupiter at 60 frames a second moving across the field of view. PIP is going to center that image and stabilize it. So it's going to go through and make sure that the image and video of Jupiter is frozen in the center. It's going to take that shifting image and put it in the center. It's not taking out any frames. It's putting it in a format that works for down the road. But if we click on this right here, we see that the image of Jupiter that was coasting across is now centered. It's jumping around a little bit. A little bit of that's the program. A little bit of that is the telescope and the fact that it doesn't track. But we have a video now, a file of Jupiter that is centered that we can take to the next step, which is going to be AutoStacker 3. I pull up this PIP file that I just took, and I'm going to have this program go through and analyze, and then I'm going to pick out the best frames out of the few thousand that I was able to capture as it moved across the field of view. You can kind of go from right to left here. You can see some examples of the highest quality frames and the worst quality frames that we have there. And you're going to make a judgment call as to how many frames you want the program to keep. For tonight, I think I picked around 75% of them. It's going to depend entirely upon what your video was and the quality of it. You then want the program to follow parts of the planet so that it can align it for stacking to make sure that the image is stacked properly and sharp. And typically, the larger these squares are, the better I've found to cover fairly large areas of the planet's surface. When you click stack here, it's going through, it's taking those best 75% of the frames of the video, and it is stacking them into one final file that I'm going to go into here with Registax. Registax is going to take this stacked image that I've put through PIP and that I've put through Auto Stacker 3, and it's going to go through and it's going to allow me to fine tune, adjust the, not really the layers of it, but really the detail. One of the first things I do is go in and do an RGB auto balance to help with color correction. I go up here to the histogram and kind of clip off a little bit of the end that I maybe overkill and maybe information that I don't need to give a more natural and impressive looking image. We then come over here to the best part of Registax. I'm going to do a zoomed view here to help out a little bit. How these wavelets work, I have no idea. I've watched YouTube videos about it. I've read articles about it. I don't get it, other than the fact that it works. And I use a different setting almost every time I use it. I'm sure there's someone out there who's cracked the code for it, but every time I adjust it a little bit differently and the results are a little different. But I go up here and I adjust the different layers from 1 through 5. I sharpen it a little bit. I denoise it a little bit to take out some of the noise from it, to soften it just a little bit to make it look more like a natural image without blown out edges, for example. And from that, I have this image of Jupiter from the wavy video that I took through all the different levels of processing. You can bump the saturation up a little bit to get a little more of that color through. Most times I would take it into a GIMP or Photoshop or something like that to do a little more fine tuning with the color correction. But this is just a kind of a quick run through of some of the free software that's out there, particularly for imaging the planets. And the result of what we just saw, we had this video here of Jupiter. We then took it into PIP. We then took it into Auto Stackered, and we pretty much got this out of it. And then after Registax, this is what we ended up with, where you have there the shadow of one of the moons beaming down the shadow on its surface. So just a little bit of the 1, 2, 3 steps using all free software, a DSLR, and my 8-inch Dobsonian telescope for these initial results for planetary imaging and planetary post-processing. Again, don't be shy about sharing these results. You've put time into this, you've put a lot of effort into it, probably even a little bit more money right now into it. If you started sharing these things on Instagram and Facebook, continue to do that, but maybe you want to start getting some advice and sharing things over on Cloudy Nights. Cloudy Nights, as I'm sure many of you know, is just a wonderful online community for any type of troubleshooting or questions about anything that we're talking about here tonight. A newer one that's come up recently is AstroBin, where you can set up an account and set up things there. That one's more astrophotography based, where Cloudy Nights covers almost everything in amateur astronomy. But, you know, take it to these websites that have people on there who have done this, who know about it. And maybe they can give you some feedback and some advice on what you can do to take what you have and maybe make it even better. Once you've imaged or started to image the solar system, it's a natural thing to want to move beyond the confines of our solar system. So let's move out of our solar system with the moon and planets using a cell phone and a telescope, or a DSLR and a telescope to at least what I do in terms of deep sky astrophotography. What's the best way to start with this? I think the best way to start with astrophotography of the deep sky is with a tripod and a DSLR. Because with that, you can do some remarkable things just from star trails. This is how I got started a couple years ago, 3 or 4 years ago now, in astrophotography, where I would just find Polaris and I would just take different exposure lengths just to see what moved and didn't move in the nighttime sky, adjust the colors, and get some just beautiful results. This right here, for example, is a 1 minute exposure. This was a 6 minute exposure, a DSLR focused and fixed on a tripod. And then this was a 30-minute exposure. And this kind of shows you where, you know, Polaris, the North Star is not exactly at the point where everything rotates. You can even see at a 30-minute exposure that has shifted a little bit as well. And then the farther out you go from it, the more you have that beautiful, almost old-fashioned Star Trek warp speed effect going on there. So use a tripod, use a DSLR, and go out and just learn how to focus on the stars, learn the nighttime sky a little more, and just mess around with exposure links, do some color enhancements to it, and see what you get. If you've done that and you want to move on further, what I decided to do was invest in my first tracking mount. And this is still the one that I use to this day. I've had it 2 years now, almost exactly 2 years, and that's the Ioptron SkyGuider Pro. I believe this is still the version of this that they have out. There's the Sky Tracker and many different companies that do similar products that are just as good a quality. But I ended up going out with the Ioptron SkyGuider Pro, which was about $500. So this was the first time I'd put some pretty decent, serious money towards the hobby. And then I decided I wanted a lens that zoomed in a little more. So I bought a used, refurbished 250 millimeter zoom lens for about $100. This lens is not going to give you perfect results, but it's going to get you closer to targets. It's about $100, and I thought it was a good starting point just to mess around. Let's see where this goes. Let's see what we want to image in terms of more things in the nighttime sky. So for about a year and a half, this was the imaging equipment and the lens that I specifically used for deep sky astrophotography. So to go through some points of the steps for this. Step one of the process is going to be polar alignment. Where Polaris is going to fall on the reticle is going to depend on where you live and the time of the night that you're out. But like I said earlier, it's not going to be at the center of it. That's the number one question I get on YouTube is should you center Polaris? You shouldn't. If you're doing any type of high focal length observing, you're not going to want to have that. You're going to want as perfect of an alignment as possible. So find Polaris, go out, polar align, make sure everything's solid, locked down. If you don't get this first step right, especially if you're shooting at higher focal lengths, even with the DSLR, even with some DSLR lenses, when you get to 300 and 400 millimeters, you're going to notice star trails if you start to do exposures that run 1 or 2 or 3 minutes in length. If you're properly exposed, the star trails that we saw earlier for about a 20 or 30 second exposure will become this. A 20, 30 second exposure where the stars probably are brighter. You're probably picking up more faint ones as they land on the sensor, but they don't move. Even if you zoom in 1-to-1 with pixels, you shouldn't see much shift or movement at all if you have good polar alignment and a pretty solid tracking mount. From there, I like to go in and adjust the settings of my DSLR. The one thing I always want to reiterate is always have it on RAW. You can get by with not having some of the other things set up correctly, but if you don't have it on RAW, you're going to lose a lot of data that you would want to use for post-processing that we'll get to in a little bit. At this point, you may start to try to figure out what your exposure or shutter speed is going to be for your target, what ISO is going to work best for your DSLR, and that can vary greatly even for cameras from the same family or brand in terms of that. So I set up the settings of my DSLR. From there, you need to find your object. And this is where I was very blessed and fortunate. I had spent about 6 or 7 years really figuring out how to navigate the nighttime sky before I got into astrophotography. If you're using something like the SkyGuider Pro, it is not going to point to what you want to look at. You're going to have to find it yourself and manually discover it. For some of the brighter deep sky objects, it can be a little simpler, but for a lot of them, it can be quite complicated, especially if you're working through light pollution. So understanding the basics of the constellations, the nighttime sky, through a lot of the Astronomical League programs that are out there, helped me out a great deal in terms of just finding the objects. So for this example here, I'm using one of probably the most imaged thing of the nighttime sky, at least of a deep sky object, and that's the Orion Nebula. I clicked the camera into live view mode. I zoomed in. I got the focus as best as I could. If you've got a Batinov mask, I bought one of those about 4 months ago. That has been a wonderful tool to just to achieve as perfect a focus as you can for your image. And then for this step, I start to take test shots. Do I want it to be a 30-second exposure, a 60-second, 90-second, 2-minute exposure? That's going to deal with the camera that you have, or the imaging sensor you have, the f-stop of your lens, basically how wide open is it, how much light is it actually letting in, and what are the capabilities of your tracking mount. For the SkyGuider Pro that I'm using right now, 2 to 2.5 minutes is as far as I can push it on most nights, shooting at around 250 millimeters. You'll find some people online that can go a little longer, a little less. I don't do auto guiding for it, which may be part of that as well. But find your object, focus on your object. Step 4. This is when the night really begins in terms of imaging. This is when you're going to take the most important thing out of all the images and frames you may take, the light frames, which are the actual images of the object. Everything after the light frames is used to help out your final image. But if you don't have properly exposed, sharp, well-tracked light frames, nothing's going to matter after this process. So this is what you're going to spend the most amount of your time on in the evening with the equipment that I'm using, is taking these separate exposures. For example, if you take 30-second light frames, about 120 of them, that's going to be roughly 1 hour's worth of data that you can stack, as we'll see a little bit later on. So light frames improve your signal to noise ratio, and they can bring out more faint detail in terms of the object that you're looking at. Stacking light frames doesn't increase the brightness. That's set more by your lens and the f-stop, but it can reveal fine detail of the object that you're looking at, the more that you get of it. After I take the light frames, I try to do maybe 1 to 2 hours of light frames, depending on the night and if there are trees in the way of what I'm imaging or neighbors' houses. I move on to flat frames. So these remove the vignetting and the dust shadows that can show up from the lens and the sensor, I believe, as well. What I do for this is I take a white t-shirt, I stretch it out as best as I can. I get a white background on my iPhone, put it up to 100% brightness, and then take about 50 or 75 of these. After that, I take some bias frames. This is where I'm just putting the lens cap on. I'm putting it up to pretty much the fastest shutter speed possible, which I think is 4,000 on the Canon camera that I use. And I take about 50 or 75 of these. These remove bias signal and read noise from the sensor. So other than the light frames, which are your image, everything else that we're talking about here is to clean up that image in post-processing, to take out dead pixels, to take out vignetting, to take out bias signal and read noise. Following that, I keep the same setup in terms of the lens cap on, and this is typically when I'm getting ready to go to bed and just kind of slowly closing things down for the night. And I keep everything set up just as it was outside, and I take dark frames. These have to be at the same exposure length as your light frames, and you want it to be about the same temperature outside or even on your sensor if you have a way of checking that as well. And again, all of these are just to help clean up the process, but the most important part of this for deep sky imaging are the light frames that we talked about a couple slides ago. So from that, we're going to take all of these images that we just shot of the light frames, the flat frames with the white t-shirt, the bias frames, the dark frames, and we're going to stack and combine them so that a program like Deep Sky Stacker, which again is wonderful to use, free software, and for what this does, I think has a pretty straightforward user experience. So for this example tonight, I ended up getting not too much, but I got about 25 separate 2-minute light frames. I took 27 dark frames, 44 flat frames, and 57 bias frames. So Deep Sky Stacker is going to go in and is going to take all 150 of these images and stack them and calibrate them and use some to take out imperfections and others to bring out detail. It's an amazing program that's been out there for quite a while and still receives free updates on a pretty regular basis throughout the year. And this is the image that comes out of Deep Sky Stacker. And the first time I saw this, I was so disappointed. I thought Deep Sky Stacker was going to do a lot of the work for me. I thought it was going to be this beautiful colors and all the cloud features of the Orion Nebula. I got this out and I was like, well, that's it. This is the raw TIFF file that comes out of Deep Sky Stacker, but you still have to do the work of bringing out the detail and of stretching the image and doing a lot of different corrections to bring out the remarkable details of it. So let's take a look at a little bit of how to do that. There are a lot of camps out there in astrophotography that will only use Photoshop, only use PixInsight. They are both good to use for different things. They can both get the job done in a great way. I personally don't exactly care for the subscription model that Adobe has gone to over the past few years. That and just being blown away by some of the features in the free trial of PixInsight had me pick this up about a year and a half ago. I switched to using PixInsight, and it's incredible software. So this right here is just a brief example of some of the steps that I take in terms of bringing out the images. This isn't nearly everything. This is just a 4 or 5 minute example. But to start off with here, I kind of do an auto exposure just to see what I'm working with. And I saw there a lot of red, a lot of oranges. That's the light pollution of where I live. Orion was right over the light dome of a local nearby city for where I live. So I went into automatic background extractor and tried to have the program figure out what's the background light pollution, what is the image. So the red and orange that you see there is the background light pollution, which means this should be a much improved image of the Orion Nebula. So just using that automatic feature and not even doing the manual one that I now use can get you really good results just to start off with. So I've gone through this image that's been taken, has been through Deep Sky Stacker, and I've taken out the light pollution. At this point, I'm going to go into it and I'm going to stretch the image. So I'm going to start to bring out some of those faint details that we all want to see in our astrophotography. So I go over here to the histogram and I just kind of slowly start moving it to the left. This is going to be a judgment call as to how much is too much or too little. Some people may do it more or less. This is when you get into the artistic side of astrophotography, which is a great deal of it. So we now have this stretched image of the Orion Nebula with the light pollution removed and with working with luminance, light, and different levels of detail that we want to do. So I'm going to go in here to something called Hdr Multi-Scale Transform. And this is going to help me go through and bring out some of the blown out details of the center of Orion. You can also correct for this by taking different exposure lengths and stacking those. But for this presentation, I just wanted to keep it a little more straightforward for it. So the program helped to kind of tap down a little bit on the brightness of what we have there. I pulled up then local histogram equalization and was going through to try to sharpen a little bit and bring out some more depth to the Orion Nebula. And you can see from these examples, you can definitely overdo it with this. This is, again, the artistic choice that you're going to make of what looks natural to you, what looks pleasing to you. You may even go compare it to what NASA takes just to see what it looks like. But this is entirely your choice in terms of what you make this final image that you're working with. So you see from there, we have some more contrast, we have some more depth coming out of it. To my eye on my computer, this is what I want my version of the Orion Nebula to look like with the equipment that I'm using and with the light pollution for where I live. This is a trick that a friend in my local astronomy club, Bert, told me about. And this was to go through and to use L-RGB combination to really go through with a luminance layer to bring out the color. And you can see here, if we kind of go back and forth, it's not a dramatic thing. You can definitely overdo it, but we've got more of the blues, more of the purples coming through. L-RGB combination is a trick I normally use, but you could go into saturation and just kind of manually move that around if you wanted to as well, similar to what we did for the histogram a little while ago. Going down here, we've got one or two more things that I'm going to do. Again, just for this, just to give you an idea of some of the things that this program can do in a brief example here today. We're going to try to sharpen it a little bit with Unsharp Mask. Going in here for that example, you can see, again, it's not a dramatic thing, but it's just something that brings out a little more fine detail, but you never want to overdo it with any of these settings in terms of making it look unnaturally sharp. A couple final things here, just some final background adjustments of the nighttime sky. Don't make the background sky pitch black. It is not, and it shouldn't look like that in your images. It's your judgment call as to how much of that pop or contrast that you want, but you don't want it to be an exact pure black for the background of space to give it a little more of a natural look. And in this 5-6 minute example here, we have the image to the left that came out of Deep Sky Stacker, and then using some of the tools of PixInsight, we have this image here, taken with a $100 lens and a DSLR that you can get now for probably around $350 or $400 used with this setup right here. So using this setup with this 250 millimeter kit zoom lens, these are some of the images that I started taking in astrophotography. M81 and M82, never get tired of visually observing them, and I image them every time they come around to a good part of my sky. These were taken with that camera and lens setup. Hercules, an incredible target right now that I'm hoping to get out and observe if the skies will ever clear over the next week or two. I imaged this with the 250 millimeter lens. The Pleiades. This is a tough one with the light pollution where I live. I'm not under horrible skies with light pollution, but this one's really sensitive to that, and light pollution filters don't work super well with it. But was pleased to get the nebulosity of those stars kind of illuminating that as the nebula clouds move in between us and them. I moved up about a year ago to buy a 50 millimeter prime lens. A prime lens is going to give you sharper images. This one also allowed me to shoot at f2 or f3, which opened up the lens to let in a lot more light, which is really one of the biggest pieces of this puzzle. So these are some images that I shot with the 50 millimeter lens. The Andromeda Galaxy, the double cluster, the constellation Orion. I was very pleased with this one. I got out to I think it was a Bortle 2 sky is where I got out to for this image in Central Virginia when I was visiting some family. Could even make out a little bit of Bernard's Loop. I'm using a unmodified camera, so some of the reds are harder to come through, but I was very happy with that one. About 4 months ago, I jumped up to the most expensive lens I'd purchased, and this opened up a whole new world of what I could image and the final details of it. About the 135 millimeter Samyang or Rokinon lens, they're the exact same lens, just with a different name stamped on them, depending on where you buy it or where you live. This lens I can shoot at f2 with almost perfectly sharp stars across the field of view. I normally stop it down to 2.8 because I like the spikes coming off the stars. It kind of, to me, is what it should look like, even though it's not, but I just like the artistic look of that. But I'm shooting with this right now for about 4 months, and this is what I'm getting with the SkyGuider Pro, my Canon DSLR, and this 135 millimeter lens. I took this 3 weeks ago of Vega in the double-double. You can make out the Ring Nebula, which is quite small, but you can barely make it out in the lower right-hand image, kind of that color that it has there. But the Vega star system just coming out beautifully right here. I love that star. Took this of the starfish cluster and various other NGC objects that surround it. The thing that impresses me the most about this lens is just the density of the star field. It can almost be too dense sometimes. The amount of stars that now show up from this lens compared to my other lens on the exact same camera just blows me away all the time. And then I took this one about 3 months ago. It was my second attempt at the Orion Nebula. We've got the Flame and Horsehead Nebula in that part of the neighborhood of the sky. And then these final two, before we conclude today, I got out again to that dark sky in Central Virginia near where my family lives. I set the camera, the lens fully open to f2. These are 1 minute exposures that were stacked to about an hour and a half's worth of data. And I was just thrilled with how the Virgo cluster turned out. Markarian's chain in particular, just the amount of density of galaxies, not just stars, but galaxies in this region of space is just something that's very, very hard to comprehend. And this last image that we have here, I have not posted yet. I'm going to be posting this on Instagram, and I'm going to be doing a YouTube video for this probably at the end of this month. I got a light pollution filter, a CLS light pollution filter for my DSLR, and it helped remarkably with where I live. And I decided to test it out on the VIII Nebula, and just the remnants of this supernova. I've seen them through the telescope, and that was enough to just be so impressive. But to image it and to get these colors and just the density of the star field that we have here from my own backyard is just, it's why I keep coming back to this hobby. This to me is just, it's something that's just hard to put words to. One of the main sources of information that I've gotten for a lot of what we've talked about here today is from a book by Charles Bracken called The Deep Sky Imaging Primer, 2nd edition. I read it cover to cover about 2 years ago, and it's like a technical manual for astrophotography. Everything down from how the sensors of cameras work to a lot of the techniques that we've talked about today. So that's just a wonderful resource to get started or to go deeper into this. Tutorials on Photoshop, PixInsight, it has everything. And also, and I can't reiterate this enough, club members. Being in an astronomy club is really what gave me a lot of the starting point in terms of what lens to buy and where to go with it for that. So just friends in my local astronomy club. How do I share the astrophotography that we just talked about? I do post it on Instagram, but something I've always enjoyed doing is video editing on the side, just kind of as a hobby for a very long time. And I decided about January of 2020 to start posting regularly on a YouTube channel that had just been sitting there for a while that I hadn't done much with. And over the past year and a half or so, I've been posting on Late Night Astronomy, where I go in and do videos for observing guides of what can be seen in the month to come, of tutorials, product reviews, just whatever interests me or the audience that's over there that people are talking about in terms of the nighttime sky. I've got a deep sky imaging series, if you're interested, that goes into more depth. It's a deeper version of what we talked about tonight. I've got about 10 videos that I've put out over the past year and a half for that. Everything from a review of the tracking mount I talked about, to how to use the lens that I did, to a hour-long tutorial on PixInsight where I go through step by step everything that I did for one of the images of the Orion Nebula that we saw tonight. So if you have any interest in that for Deep Sky Stacker, how to take light, flat, dark frames, please feel free to check that out and leave any questions and let me know if you need anything at all in terms of getting started in this. I've got some planetary imaging series as well for those of you that have telescopes and want to try to image with a cell phone or with a DSLR camera attached to it like we talked about earlier. So again, if you're interested, feel free to check those out and let me know if you have questions. And I just started this month a new series called The Night Sky, where I'm hoping and planning to do one of these videos at the start of every month looking at what's in the night sky for you. If you don't have a telescope, what can you see? If you have your first telescope, what can you see? If you have $1,000 telescope, what can you see? If you're taking images of the night sky with your phone, with a DSLR, with advanced imaging sensors, what can you image? Kind of from beginner, intermediate, and a little bit into advanced users, what's out there to enjoy of the nighttime sky. So if there's one thing I want to end with tonight, how can you share your knowledge of the heavens above? Number one, talk about it with people. Don't be shy about what we do. Go out there and show people your pictures and videos. Talk to them about going out with your telescope. Friends and family, co-workers, let them know what you're doing. Number two, post pictures and stories about your experience on social media. Whatever social media platform you like to use, post it, let people know what it is you're doing, what it is you're imaging or going out to visually observe. And number three, cannot reiterate this one enough. And I know I'm preaching to the choir here. Join your local astronomy club. I honestly do not think I would have the confidence or knowledge to do what I do today with imaging or post it on YouTube if I hadn't joined my local club 6 or 7 years ago and met people who were doing these things that interested me and gave me great information on how to get started on it. So join your local astronomy club. And with that, I want to thank you all again so much for having me here. And if there are any questions that you have, please feel free to let me know. But thank you again for the opportunity.
Great. You do have some comments, questions. There's a gentleman that has a mount that is just like yours, and he says, I use the Polar Clock app on Android. And he's wondering, where should Polaris be in the rings? He says, I usually just set it outside the second inner ring.
That's the one that I normally use as well. I have another app on my phone. I think it's called Polar Alignment Pro, possibly. But yeah, typically it's on that second outer line. But depending on when you go out, it may be at the 11 o'clock position or the 1 o'clock position. You only have to do it once at the start, but it's going to be at a different point depending on when you do the initial alignment.
Okay. All right. Someone else asks, do you use photometric color calibration?
Yes, but that's a great question. That's very good timing. So I use that, and that's a newer feature of PixInsight. But I've found that I have trouble using that when I use a light pollution filter on my DSLR camera. It may be because I'm using a light pollution filter on an unmodified camera, but I've actually found that just neutralizing the background and doing a standard adjustment to the colors actually gets a more accurate image than photometric. But prior to that, I'd use photometric for everything that didn't involve a light pollution filter.
Yep. Andrew Corkill says, really great presentation for a DSLR. Let's see.
Thank you very much.
Cameron Gillis says, those are great pics, Michael. Nice pictures from Beatrice Hines. She's also an astrophotographer, so is Cameron. Let's see. Excellent presentation, Michael. Very well done. That was from Jeff Wise.
Keep them coming. I love these comments. This is great.
Yeah, Andrew Corkill again. Fantastic presentation, Michael. Oh, Beatrice Hines is now a subscriber of your channel. So there you go.
Always appreciate that. Thank you.
Yeah. Phil McDonald, great presentation. Thank you. I'll definitely be subscribing to your channel.
Awesome. Thank you.
Jeff Wise, he subscribed. Pekka Hautala in Stockholm says, I like Michael's tutorials on YouTube. I've seen every single one.
Well, thank you very much.
Yeah, that's great. There's a conversation just about posting images. Norm Hughes says, I even post my bad images in an attempt to show that imaging isn't cut and dry. Excuse me. I got a beautiful image that we do have, but we do have troubles and bad nights.
I think that's a very good point to make. Is just post what you have and don't be your own worst critic about your own work. Enjoy it and just post what you've taken.
Yeah, Beatrice Hines says, I do that too. It's important to show others and also to myself. I like to see and learn from my evolution in astrophotography. And that's what it is, you know,
Exactly.
all these techniques, honing your skills and everything. You know, you're an explorer, you're exploring, and you know, the better you are, the more skilled you are with the gear you got, you know, that takes you on a ever increasing path, you know, of understanding your place in the universe. So,
Exactly.
yeah,
That's true. Michael, thank you. One thing I noticed when you were speaking, we have so many people out there that are beginners. One of the first things I think you experience is you need to learn your camera and how to operate that camera in the dark. You need to be, because you're always turning on lights. If anybody's around you, they're not going to be happy, but you realize very quickly you've lost dark sky adaptation.
Right.
And that becomes a big factor. And I use the same SkyGuider Pro that you do. And I honestly believe most star trackers out there is a great way for a beginner to start, because now I auto guide with my SkyGuider Pro. And it's a way to grow without spending more money until you get really experienced in what you're doing. So exactly. I think that's a great way to start. You have a lot of room to learn there by going just from a DSLR to a camera lens, then learning auto guiding with that same camera lens and camera in the same guide, you know. And the one thing that surprised me since I've just started in deep sky imaging is I really thought, you know, if I have a good night Thursday night, when I shut down, when I go back out Friday, everything's going to be perfect. And it has been a real hit in the face to realize everything can be perfect the night before. And when I go out the next night or 2 nights later, everything is wrong and I've done nothing. And you have to figure it all back out again. But right. It is an exciting challenge. It is great. It keeps your mind going. And you can't beat a great night under the stars. I don't care what anybody says. Give me those clear skies. It doesn't get any better than that. So thank you so much. If anybody has any questions here.
Michael, I just wanted to make a comment. I just looked at your YouTube channel. You've got a ton of great information out there, not only about imaging, but what's up in the sky for the following months and so on. And so, yeah, you've got a great publication out there.
Thank you.
Nice.
It is. I'd invite anybody subscribe to it. I went through it last night and a couple nights ago. You've got a lot of great information there to help people of all levels. And that's what I think we all need. We can all learn from each other. So thank you so much for that. Are there any more questions before I give the answers to the questions that I asked? All
let's
right.
see. Beatrice Hines just makes a comment. Astrophotography is all about learning from your failures. Always trial and error.
Yep.
Okay.
All right. I am going to give the answers to the questions then. And thank everybody that has answered them. Oops, I better share my screen first. And my dog is going to start barking, so. All right. First question was, what date was the final shuttle launch? And it was July 8th of 2011. We just celebrated just few days ago, the 10th anniversary. I cannot believe it's been 10 years from the last shuttle launch. Long time ago. Kevin is the winner. Kevin didn't give us his last name, but we've got his email address to contact him. So thank you, Kevin. Second question, July 3rd, Sunspot AR 2838 did something we haven't seen in 4 years. What happened? It burst through the surface of the sun and promptly unleashed the strongest solar flare in 4 years, an X 1.5 class explosion. And I love the aurora. I was checking to see where that was at and if it was going to be Earth directed, which naturally it wasn't. But Norm Hughes got that right. So thank you, Norm.
Mhm.
Last question. What's the approximate dollar amount of the door prizes, Alcon Virtual? We're right around $7,500. And Mike Napier got that right. So congratulations, Mike. And either Carol or somebody from our national office will be contacting you to get information to where to ship your door prize. And I would like to mention Astronomical League 9. We will be doing Alcon Virtual in August. So we will not have a per se Astronomical League Live next month because we'll be busy with the conference. We will be back in September with Astronomical League Live. So please make sure you join us then. And that's the end of mine. Okay, so thank everyone. Thank my speakers. My gosh, I know all you guys, Michael, now I know you, but thank you all. Everything that you did tonight was just plain amazing. Thank you for an incredible program. We couldn't have done it without each and every one of you. And Scott, thank you. We sure couldn't have done any of this without you.
Thank you very much. It's my pleasure.
Thank you. If anyone else has anything they'd like to say before we close, please feel free.
Zip shut. Okay.
Time I see John zip his mouth. All right. Thank you, everyone. Thank you, everybody, for tuning in. Thank you for all the answers, all the help, and the support. We will see you, hopefully, August 19th to 21st for Alcon Virtual. Please join us, and we will see you then.
Take
Bye-bye.
care.
Night.
Thanks for watching, everybody.